Okay, continuing our examples. Okay, we're going to move on to 5.6, and this was imaginary and complex numbers. Let's see, we started off with simplifying complex numbers. So if we have, let's say we've got the square root of negative 25, we can simplify these the same way that we simplified other numbers. The negative can break off on its own. 25 we know how to do. The square root of negative 1 is defined as I, and then you simplify the regular square root just like we did before. So square root of 25 we can do, that's going to be 5, and then we usually write that as 5i. So if you have, let's say we've got square root of negative 18. So we can deal with the negative 1. Okay, take the negative off by itself. So we can't take square root of 18, but we can break it up as 2 and 9. Okay, so just like before, we break it into pieces that we know. This is I, this is 3. We can't do anything with the 2. So we're going to have, I'm actually not sure how they would want this written. You could write it as 3i square root of 2, or you could write it as 3 square root of 2i. I think probably 3 square root of 2i would be the preferred method. Even though you usually put square roots at the end, like for x's and stuff, I think I trumps that and it comes at the end on its own. Because they usually want it in the form a plus bi, so the whole coefficient goes there. Okay, and then when you're multiplying and dividing, you've got to remember to convert to I first. So let's say you've got like, let's say we've got negative square root of 2 times negative square root of 10. So before we would have multiplied those together and we would have gotten positive square root of 20, but that's not the right way to go because that completely gets rid of the imaginary part of this. So you don't want to multiply first, you want to simplify first. So we're going to do negative 1 times 2, and we're going to do negative 1 times 10. Okay, we've got to make sure that we take care of those negatives first. So this is I, this is I. Now we can put it together. We get I times I is I squared, and we get square root of 2 times square root of 10 is square root of 20. All right, now you look for things that you can simplify. So I squared, that's one of the ones, we'll talk about this in just a minute, but that's one of the ones that you need to remember. That's going to be negative 1, because remember that I is the square root of negative 1, and if you multiply any square root by itself, you get what you started with. So I squared is basically defined to be negative 1. Square root of 20 we can simplify as 4 and 5. So we're going to get negative 1 times 2, that would be negative 2 square root of 5. Okay, so we don't want to multiply in the first step. We need to simplify it in terms of I, and then we can multiply them together when they're real numbers. Any questions on that before we move on? Because those are kind of important basics. Okay, so the next thing that we did in this, actually I'll keep that there. So powers of I, basically if you remember that you've got I and I squared is equal to negative 1, then you can do powers of I. So the other one that you need is that I to the 4th. I squared times I squared would be I to the 4th, and that would be positive 1. So I run through the first I squared, I cubed, I to the 4th in the video. You can go back and watch that if you want, but these are the keys to remember, I squared, and I to the 4th. So basically if you have any multiple of 4, it's going to be 1. So I to the 4th is 1, I to the 8th is I to the 4th squared, still 1, I to the 12th, still 1, I to the 16th, still 1, I to the 20th, still 1, and so on. So when you're looking at powers of I, you want to reduce them by multiples of 4, and then whatever's left over you look at as either I and I squared. So let's try that. So let's say that we've got I to the 19th. So you want to factor out the biggest multiple of 4 that you can. So the biggest multiple of 4 that fits into here is 16. Okay, so 4, 8, 12, 16, 20. 20 is too much, so 16 is the biggest I can fit in. And then I've got 3 left over. So I to the 19th is the same as I to the 16th times I to the 3rd, because we would add the exponents. I to the 16th is a power of 4, so that's just 1. So that means that I to the 19th is the same as I to the 3rd. We can simplify this because it's the same as I squared and I. And we know that I squared is -1. So -1 times I is equal to I. So all of these you should be able to reduce down to plus or minus 1, plus or minus I for your final answers, all of them. Okay, let's try one more. Let's say we've got I to the 41. I to the 41. So the first thing you do is you look for the biggest multiple of 4 that you can fit in here. So that would be I to the 40. And then you're going to have 1 left over. I to the 40, that's a multiple of 4, so that's equal to 1. And I to the 1 is just I. 1 times I, we just get I again. Okay, so the first thing you do is you look for the power of 4. You use this one as the key. And then simplify whatever you have left. Are there any questions on that one? Okay, I don't see any questions, so let's go on. So now operations with complex numbers, a plus bi. So a and b are real. Complex numbers can always be written in the form of a plus bi, like 2 minus 3i, or 4 plus 5i, things like that. Okay, so number I. Adding them together, adding, subtracting, and multiplying are just like if they were x's. So let's say that we do 2 minus 3i plus, well, we'll do 4 plus 5i. I think I already got these two here. Okay, so adding these together, you're just going to add like terms. So we're going to put the 2 and the 4 together to get 6. Negative 3i plus 5i would be 2i. Okay, so just like if they were x's, you would add like terms. Subtracting is also very similar. You just have to remember to distribute that negative first, and this would be the same as if they were x's as well. So we need to distribute that negative. We get 2 minus 3i minus 4 plus 5i, and now we can group like terms. So we would get negative 2 Oh, I changed the problem. I'm sorry. I'm like, how am I getting the same thing? Sorry, this should have been 4 plus 5i. So when we distribute, this would be a negative I. There we go. And then we would get, sorry, I changed the original problem. All right, so we distribute that negative, and now we would get minus 8i. Okay, so nothing different there as far as i's go, same thing. Multiplying them, 2 minus 3i times 4 plus 5i, you're just going to FOIL this out. We're already familiar with that. So we're going to have 8 plus 10i minus 12i minus 15i squared. And then we can collect like terms just like we would if these were x's. And the biggest difference now, the FOIL part works the same, the biggest difference now is that we can simplify I squared to be negative 1. So we're going to group like terms, we're going to get minus 2i in the middle, and I'm going to put negative 1 in here for I squared. That's going to give me a positive 15 here. And now that it's positive 15, I can put that together with the other real number and get 23 minus 2i. Okay, so for all of these, you should always be able to get back to a plus bi. All right, and then the last one for this is dividing. Dividing is the one that's a little bit tricky, but it's very similar to what we just saw with rationalizing the denominator. So So let's say we have 2 minus 3i over 4 plus 5i. We have a complex conjugate, just like we had a radical conjugate, and it works the same way. You want sum and difference. So here we've got a sum. Our complex conjugate would be the difference. We want to get the complex number out of the denominator just like we wanted to get the radical out of the denominator. So we multiply by the conjugate on top and bottom, and we FOIL just like we saw before. So we're going to have 8 minus 10i minus 12i plus 15i squared. Oops. Minus 12i plus 15i squared. Okay, so that's our top. The bottom you can FOIL out, but the two middle terms are going to cancel out, which is what we want. So you really just have the first and the last, because it's the difference of two squares. So we're going to get 16 minus 25i squared. Okay, and then you're going to have 20 plus 20i minus 20i. If you want to write that out, it's always going to cancel out. All right, so we did all the FOIL, and now we're going to simplify. So on top, we've got 8 minus 22i. I can put those two together. And then again, remember that I squared is -1, so this is going to be minus 15. On the bottom, we've got, again, this is -1. We're going to have 16 plus 25. Okay, so I'm replacing those I squareds with a -1. That's going to change the sign out front. So on top, we can put these together. We're going to get -7 minus 22i over 41. All right, now this may seem pretty complicated, but when you look at it, now we've got a plus bi on top, and we just have a single number in the denominator, and that's what we want. So if we want to, and I think your homework wants you to, you can break this up. You'd have -7 over 41 minus 22 over 41i. This is the A and the B that they're looking for you to input for the homework. Okay, so you just take that number in the denominator and you break it up. It's like the opposite of getting a common denominator. Oh, and I guess we skipped the simpler version of, dang it. Hold on, I just moved the whole screen. Okay. The simpler version of that would be if you have just if you want to rationalize and you just have a single I in the denominator. So let's say we've got, like 3 plus 6i over 2i. Okay, so for this one, I don't need to multiply by the conjugate. I need to get rid of the I, but I can just multiply by I over I because this is a single term. So just like before, if you had a radical, you multiply by itself. But if you had a binomial, you had to multiply by the conjugate. For this one, we don't have to multiply by the conjugate. We can just multiply by I. So we're going to distribute. We're going to get 3i plus 6i squared. And on the bottom, we're going to get 2i squared. And then we're going to simplify these I squareds to be -1. So we're going to get 3i minus 6 over -2. Okay, so if it's just a single term in the bottom, you just need to multiply by I and that'll fix it. There's no conjugate for a single term. Okay, just multiply by I and simplify. And then to get this in the form that you want, you break up each piece over -2. So we're going to have 3 over -2, or -3 over 2. And then 6 over 2 would be 3, and that's going to come out positive. So this is your A, this is your B, or you can reverse it. So this is your A, and this is your B. The B is always in front of the I, the A is always by itself when you go to put these in the homework. Okay, any questions on 5.6? I'm actually going to have to stop this video again. Come on now. Sorry, I pulled up a PDF. I can't. I'm trying to stop the video. There we go.